Hi, welcome to In 5 Minutes. We have seen different problems for N channel EMOSFET. Now we have the voltage divider biasing, the same biasing technique, but now we are using the P channel. See the arrow, since it is pointing inwards from the drain towards the gate, it is P channel MOSFET. In the previous case we had the symbol in this format. It is N channel MOSFET, now it is P channel MOSFET. Again, the biasing technique used is the potential divider biasing. So our first step in the solution, we find the value of Vg by potential divider biasing, which is R2 upon R1 plus R2 into VDD. So this will give me 50 upon 100, it will be half. So half of 5 volts will be 2.5 volts. So I have got the value of Vg. Now the formulas in the P channel MOSFET are slightly different. So during the solution only I will mark the difference. Then once we know Vg, we can find VSG, that is the voltage between the gate and the source. VSG, we can find it out. This is your source, this is your drain, this is your gate. Now in this case the terminals become source, but the current is the drain current. So since the drain, we have resistance RD. So we can find VSG by applying KVL as VDD minus VG, right? So it will give me, that is the voltage between, at one terminal is connected to VDD, other terminal is connected to VG. So we can find VSG as the difference between the two voltages. That will be 5 minus 2.5. This will give me again 2.5 volts. Now we can use the basic formula when the transistor is biased in the saturation. So what we can do, we can assume the transistor is biased in the saturation. You can say transistor is operating in the saturation region. We can say ID, since it is now P channel, we are, instead of Kn we are writing it as Kp, which is given in the question as 0.2 milliampere. Now VSG plus VTP. Now what is the change in the formula is, instead of minus VTN you have plus VTP even in the formula. So when you substitute the value, you will get ID in this case as 0.578 milliampere. So we've got the value of ID as 0.578. So we can find VSD as VDD minus ID into RD. So this will give me VSD as 0.665 volts. We are applying KVL from this point to the ground. So that is VDD minus ID into RD will give me 0.665 volts. And find VSD SAT. That is the value of VSD at the saturation region, which is VSG plus VTP. This we have done the formula. VSG is 2.5 volts, which we have found, and VTP is given as minus 0.8. So when you substitute, you will get VSD SAT as 1.7 volts. Now we got VSD in our case as 0.66 and VSD saturation is 1.7. So if it is operating in the saturation region, it should be above 1.7. But since the value of VSD is less than VSD SAT, the P channel MOSFET is not biased in the saturation region as assumed earlier. Since we have used this formula, it is valid only in the saturation region. But since your VSD is less than this saturation value, we cannot apply this formula. That is, transistor is not operating in the saturation region. Your VSD should be greater than VSD SAT, then only it is operating in the saturation region. So we cannot apply this formula for finding ID.